Hey, hi everyone. So we have covered CNN, convolutional neural networks. We understood how and why convolution is applied, and then pooling is applied, and how combination of convolution and pooling um, together does a similar function as a single neuron. What we also understood is a huge image. Um, like you remember we have seen that n by n, and then we were actually moving this kernel. So um, we are breaking it down. So the overall image that is there, we are breaking it down. Inputs, breaking each pixel is n by n pixels. Each pixel is considered as input features. So what we are doing is uh, we are breaking down the whole input into smaller boxes. How do we break it down into boxes is basing on the way the kernel moves. Like if you represent it as an n by n matrix, we are taking inputs as uh, as the box moves, and moving that kernel across a kernel or filter across the image, and the steps are called strides, and moving it across, we capture the inputs, and the input features are actually fed into um, to the network. And um, if you feel that there is accuracy problem of especially if the images have some important data in the edges, then we actually go for padding, so that the edges also have are also considered significantly as the internal pixels. So um, so overall, if you look at it, this each kernel has certain weights. Like let's say f into f matrix, then it is w1, w2, w3, w4, and those weights. And this image that is this is split into smaller parts, like small parts. These small parts were fed into this particular, each input is given to one neuron, and each neuron, the weights are equivalent to the kernel filter weights, and the activation function is pooling. The pooling has max and average. So broken down inputs are given to individual neurons. For one kernel, there will be X number of neurons as per how many parts you make the inputs into, and those neurons will do a first function is W1, like matrix multiplication kind of stuff between the filter weights and the input data that is given, W1 x1 plus W2 x2 plus W3 x3. Um, and then we have activation function is either average or max of. Um, Wait, one second. Pooling, this can't be my understanding is wrong, because I'll carry this same understanding. The pooling is not applied on single input and single kernel. I can't bind pooling to the convolution layer, individual layer at least. The pooling is applied on, what happens is, as convolution is done, pooling is similar to convolution. Instead of multiplying with certain parameters, what we do is, we again, the output of convolution, we broke it down into smaller parts, and those paths will be given to another function, either average or maximum, and that will give a certain output. So pooling helps in scaling down the image, whereas convolution helps in identifying the patterns. These two can't be combined into a single neuron. These actually are two different layers. Correct. My understanding of putting it into neuron where activation function is the pooling and calculation is this is wrong, because in between, I mean, if the inputs are same for both of them, then we can put them into one neuron, but the inputs are not the same, right? Output of this particular kernel, let's say we call them A11, A12, A13, A14, A15, A16. In this, again, the pooling will take subparts of it similar to basing on it also has a filter kind of stuff which doesn't have parameters. Uh, so, but it moves those filters and say A11, A12, A14, A15, like that, like 2 by 2. Let's say a filter is 2 by the filter is 2 by 2 for a pooling is 2 by 2. Then it takes the 2 by 2 and it does apply a function on top of it. So max of kind of stuff. So um, these both can't become these both can't be connected to each other. These both should actually be considered as two different layers. Only thing is, yeah, that's it. And pooling can be applied across all kernels, and but output one at a time. Yeah. So convolution pooling for one kernel, convolution pooling for one kernel, convolution pooling for one kernel. All of them are separate. Um, if we use three kernels, then we get three kernels will get three outputs after pooling, and three outputs will be flattened and then given to a ANN forward neural network, and then that will actually have some kind of a sigmoid or softmax functions for either class binary classification or for multi-class classification, and they can give certain output like like an object detection within an image, like all cars, bikes, human, three things we want to classify. Then there can be a softmax function, and that can actually classify, saying, okay, these are all cars. These are all. I mean, there is a car at least. There is a bike, and there is a human. That's some output that it can give. At the same time, it can also give us saying where that particular the object detection. It can also say where that particular uh, object is. For example, it has detected a car. The CNN can say that there is a car based on what we have learned. How do we say in which position? Because after pooling and stuff, we are kind of losing on the actual image coordinates and all that, because we are kind of encoding it the actual image n by n into something smaller using this convolution and pooling concept. So now once the output comes in, traversing back to say this is the part which influenced, and because of this part we are saying is a car, that can't be, I think that can't be said by CNN. So in that case, then we need to figure out how do um, we do. That's a good question to ask. Let's ask ChatGPT. Can we do object detection with CNN? Those are commonly used for object detection, right? Including object detection and mapping images. For the task because they are designed to recognize species. This combination. Yes, here's model selection, training, evaluation, deployment, mapping. Joins recognize patterns and pieces of objects within a warning labels. That is okay. As overlaying the bounding boxes or markers representing the vector objects onto the image. How does CNN know the boundary of parent? That learn hierarchical representation of physical units. He will repeat the same story again. It is training. Can perform boundary detection by training. Mail processing can. Oh, RCNN is region based CNN. Forward passport. Evaluation of the image data. It raises a- How does this happen? Is the question. Cover objects in minimum of regions possible. To reach answer is to cover one object. The proposed innovative hierarchy is to generate segmentation. అదేదో రాసేసాడు. Outline of image directed using CN. Diagram. Like usually means finding out. What's the matter? So there would be some pre-processing done on the image where we segregate the image into smaller parts, and the smaller parts are given to networks. So giving everything together in one piece kind of stuff. So where multiple people are. The well-used technique in OpenCV for recognizing and the wallet object. And objects which is uh, hard cascade algorithm. Discover object relation with hard cascade algorithm using OpenCV. Learn how to apply this concept. For example, non-diamonds concept implications. Organized development texting motivation to connect keep your skills. Object detection. Identifying a custom object in an image is be done using sound. Okay, what is happening? It's cascading. Learn about counters. Factor counters. When we join all points of the boundaries of an object, we get a counter. A specific counter refers to the boundary pixels that and density offensive makes it really easy to find. And so it depends on the boundaries and stuff. It is detecting what is the like counter detection. Chain approximate simple and chain. There's in detail in the examples below. The counters of simple objects. Okay. We'll come into grayscale format. Okay. He didn't explain on. He gave methods. Okay. Binary image after applying the threshold function. Okay. Display the image. It's not single. It's just so. So there are almost no differences between almost of the great cost. Nothing comes to explore and interesting and level to encourage how other case as well. Let's go with it. Objects in an image are strong. Great object puppy, but also the background not done with it. It's object in turn. And everything. Huh. Hmm. Nice. Okay, now let's get to brief on what we need to study about RNN. Okay. And the different model that is trained to have process and convert a sequential data into sequential data input into a specific sequential data output. That is just word sentence or time series data where sequential components and based on the complex semantics and okay, start quest. Let's see. we look at the basics of RNN, it is not completely clear, but we understand. And what- So we'll continue more on RNN tomorrow. We have explored CNN more today, which we not expecting without starting off with RNN, but CNN we had some few right questions to ask because we just thought, okay, image comes and then we classify the image and then call it whether it's a dog or a cat. It's as simple as that. But the and the more to it as we do in the image classification is more object detection, but the key question that came in is like how do people do object detection using CNN? But the answer is CNN doesn't do um, see object detection and object labeling. There are two concepts. Object labeling is could be done by CNN, but object detection is not being done by CNN. Object detection is being done by other tools like OpenCV, and that doesn't actually, I mean, technically, point is that doesn't need AI or network-based tools. We can actually do it using normal OpenCV based means or algorithm-based applications, which can actually detect the edges within these images, which actually gives multi-levels also. What is a parent, what is child, and all that stuff. So that and this is independent, but that being done and the object boundaries being recognized, those can be given as inputs to CNN, and CNN in turn can label them. Like let's say you detect 10 objects with boundaries. These 10 objects can be separately given to CNNs, which are trained specifically for those objects. And that can actually give us an accurate result. That's how it is. Yeah. Okay. See you. Thanks. Bye.